We're working with the Advanced Functions and Modeling Indicators, Standard 1.01. This standard is talking about different types of functions. And so let's get right into it. Example 6. The High Roller in Las Vegas, Nevada is the world's largest Ferris wheel. The wheel is approximately 550 feet in diameter. The wheel was designed to turn continuously and to be slow enough for people to hop on and off while it turns, completing a single rotation once every 30 minutes. Suppose you board this Ferris wheel at ground level. Let T represent the time since you boarded in minutes, and let H represent your height above the ground in feet. So the first thing we must do is we must fill in this table. Now, I know based upon what the problem gives us, it says a single rotation once every 30 minutes. So what that tells me is that if you get on the ground, okay, so it says suppose you board this Ferris wheel at ground level. So you board the Ferris wheel at ground level. Then after 30 minutes, it's going one full rotation. So it's back at the ground here at 30 minutes, and then it's back at the ground at 60 minutes as well. Okay? Now, let's think about this. Half of 30 minutes is 15 minutes. So if the diameter is 550 feet, then halfway between it's going to be 550 feet. Okay? Because this Ferris wheel is going to go one full rotation in 30 minutes. So in 15 minutes, it's going to be all the way up in the ground, in the air. So you'll be at the highest level at 15 minutes, and then you'll be at the highest level at 15 minutes here. And then so these in between points, you'll be halfway between the maximum height. So we want to say 275 there, 275 there, 275 there, and 275 there. So once again, we just basically didn't have to do any calculations. We know that because it has a diameter 550 feet, that the maximum height of this Ferris wheel is going to be 550 feet. Okay, now let's go ahead and do something else. So let's say in this case it says which function, sine or cosine, would best fit the data. So I'm going to say that the sine function would fit the data best. Sine function. Why? Because the sine function, when x is equal to 0 or the initial value, the sine function equals 0, versus with the cosine function, when x is equal to 0, the height is at 1. So we know we want to go with the sine function for part B. Now, part C says find a regression model for the given data. So we have to actually go in and plug in these values into L1. These values go into L2. And when I plug in these values, notice it will tell me y is equal to a times sine of bx plus c, and then plus d. And that's what your calculator will tell you. And then it tells you that a equals 275, b equals 0.2094, c equals negative 1.57, and d equals 275. Okay, so our regression equation is actually y equals 275 times the sine of 0.2094x minus 1.57 plus 275. Okay, so from there we want to, so this is part C. Okay, this is part C. From there, when we get to part D, it asks us describe the period and the amplitude. Well, we know in order to find the period, we have to do 2 pi over b. And in this case, b is 0.2094. And when we calculate that, we get approximately 30. So the period really, notice this 30, it goes back up to the problem. It says a single rotation once every 30 minutes. So this 30 just represents that the Ferris wheel makes one full rotation. So the period says that it makes one full rotation every 30 minutes. So that's what the period represents in this case. Okay. It also talks about the amplitude. Okay, so let's underline period. And now the amplitude. Okay, so the amplitude in this case, we want to find the amplitude, which in this case is 275. It's A. Okay, 275. So what does that represent? That represents that the Ferris wheel, it goes up 275 feet from the center and down 275 feet from the center. So maximum point, maximum height is 275 feet above center, and minimum height is 275 feet below the center. Okay, so that's the period and the amplitude. Okay, now last but not least, it says, is there a phase shift or vertical shift applied to the model? If so, explain why it is necessary. Well, let's look at this. Okay, I believe that there is a phase shift. Okay, so we're going to say PS. And the phase shift is C over B. So if I have 1.57 over 0.2094, that is approximately 7.5. Okay, now notice this 7.5, notice right here in the table, after 7.5 minutes, the height is 275. So every 7.5 minutes, the height is 275. Boom, boom. So every 7.5 minutes, the height is 275. So that represents the phase shift, because we know that the Ferris wheel not only rotates horizontally, but it also rotates vertically. So as time goes on, it rotates, it oscillates back and forth horizontally, and it also oscillates up and down vertically. So the phase shift just represents that the wheel goes up. Let's see, the wheel goes up 275 feet from the center. Okay, and down. So this is basically the same thing that I've stated here, and below center. Okay, and I can't write over that, but this is an excellent problem to model using the sine function. So look over this, and hopefully you can get a better understanding of this particular indicator example.